Let's talk about something really cool. Artificial intelligence, or AI for short. Think of AI as one giant, incredible idea. It's the grand dream of making machines that can think, reason, and solve problems just like humans do. The goal is to build something that can perform tasks that would normally require human intelligence. It's not just about calculators doing math really fast. It's about creating systems that can understand, learn, and adapt. When you imagine robots in movies that can have a full conversation or make a clever plan, that's the ultimate vision of AI. It's the broadest, most all-encompassing category we have for smart technology. Now you might be thinking, Bill, where can I see this AI stuff? Well, it's already all around us. When you ask your smart speaker, hey, what's the weather like today? And it answers you, that's AI at work. It understands your words and finds the information you need. Have you ever played a game of chess against a computer and it made a move that totally stumped you? That chess engine is using AI to think ahead, strategize, and try to win the game. It's a form of intelligence, but it's artificial, made by us. These systems are designed to mimic human cognitive functions in very specific ways. Consider the concept of a self-driving car. The entire vehicle, with its ability to navigate from one place to another without a human driver, represents the big idea of AI. The car's mission is to perceive its environment, make decisions, and control its own movement, all tasks that a human driver would perform. This is a perfect example of a complex system built to achieve an intelligent goal. The car isn't just following a pre-programmed path like a toy on a track. It's actively making choices based on what's happening around it, which is the very essence of artificial intelligence. So to wrap our heads around this first big concept, remember that AI is the whole field of study. It's the umbrella term that covers any technique or technology that enables a computer to simulate human intelligence. This can include everything from simple rule-based systems, like a thermostat that turns on when it gets cold, to the much more complex systems we'll talk about next. AI is the science and engineering of making intelligent machines, and it has been a dream of scientists and storytellers for a very, very long time. And now, that dream is becoming a reality, one smart device at a time. Now, how does a machine get smart enough to be called intelligent? One of the most important ways is through something called machine learning, or ML. Machine learning is a specific part of AI. Instead of giving a computer a long list of rules to follow for every single situation, we give it a bunch of data and let it learn the rules for itself. Think of it like this. You don't teach a child to recognize a cat by describing its pointy ears and long tail. You just show them lots of pictures of cats, and eventually, their brain figures it out. ML does the same thing for computers. Machine learning is what makes many of our favorite apps so smart. When your email inbox automatically sends a fishy-looking message to the spam folder, that's ML. The system has learned from millions of other emails what spam looks like, so it can spot it on its own. When a streaming service recommends a movie you might like, it's because ML algorithms have analyzed your viewing history and compared it to what other people with similar tastes enjoy. It's not magic, it's data. The machine is learning patterns and making predictions based on them. There are a few different ways machines can learn. One way is called supervised learning, where we give the computer labeled data, like pictures of dogs with the label dog and pictures of cats with the label cat. Another way is unsupervised learning, where we just give it a jumble of data and ask it to find interesting patterns or groups on its own. And then there's reinforcement learning, which is like training a pet. The machine tries something, and if it does a good job, we give it a virtual treat. This is how computers learn to play complex games and even control robots. So, machine learning is a subfield of AI focused on building systems that can learn from experience. It's a powerful tool that moves us beyond simple programming. Instead of telling the machine exactly what to do, we're teaching it how to learn what to do. This ability to improve over time with more data is what makes ML so revolutionary. It's the engine that powers so much of the smart technology we interact with every single day, making our digital lives more personalized, efficient, and secure. Consider the following. Every time you use a translation app, you're witnessing ML in action. Alright, let's dive even deeper. Inside the world of machine learning, there's a super-powered technique called deep learning, or DL. If AI is the whole car and ML is the engine, then deep learning is like a high-performance, turbocharged part of that engine. It's a special type of machine learning that is really, really good at finding complex patterns in massive amounts of data. It's inspired by the structure of the human brain, using something called artificial neural networks. These networks have many layers, and the deep learning refers to how many layers are stacked on top of each other. These deep neural networks allow the machine to learn in a much more sophisticated way. Think about unlocking your phone with your face. How does it know it's you? Even if you're wearing a hat or it's dark outside. That's deep learning. The first layer of the network might learn to recognize simple things like edges and colors. The next layer might learn to combine those edges to find shapes like eyes and a nose. The layer after that might learn to put those facial features together to recognize a face. By passing information through all these layers, the system can learn incredibly complex and abstract concepts. You see deep learning in action more often than you might realize. When a doctor uses a computer program to help spot tumors in a medical scan, that's often a deep learning model that has been trained on thousands of other scans. When you speak to a voice assistant and it understands the nuances of your speech, or when an app translates a sentence from one language to another in real time, that's the power of DL. These tasks are too complex for simple ML. They require the ability to understand subtle patterns and context, which is exactly what deep neural networks are built for. So, deep learning is a specialized subset of machine learning that uses deep neural networks to solve very complex problems. It requires a lot of data, way more than traditional ML, and a lot of computing power. But the results can be astonishing. It has pushed the boundaries of what's possible in AI, leading to breakthroughs in fields like computer vision, natural language processing, and medical diagnostics. It's the cutting-edge technology that is making our machines not just smart, but incredibly perceptive. It's science, and it's awesome. Let's get back in our self-driving car to see how these three ideas, AI, ML, and DL, all work together. The big overall goal is artificial intelligence, to create a car that can drive itself safely from point A to point B. This is the grand vision, the challenge we are trying to solve. The car needs to perform the intelligent task of driving, which includes perceiving the world, planning a route, and operating the vehicle's controls. The entire system, working together to achieve this human-like task, is an example of AI. It's the whole shebang. Now, how does the car learn to do all this? That's where machine learning comes in. Engineers don't write a rule for every single thing that could happen on the road. That would be impossible. Instead, they use ML. They feed the car's computer system enormous amounts of driving data, hours and hours of video from real roads, sensor data, and information about how human drivers react. The ML algorithms learn from this data. For example, it learns that when the car in front puts on its brake lights, it's a good idea to slow down. This is ML. The system learns patterns and behaviors from data. But what about the really tricky parts? How does the car tell the difference between a pedestrian, a bicyclist, and a shadow on the road? This requires a very sophisticated level of pattern recognition, and that's a job for deep learning. The car's camera systems feed visual data into a deep neural network. This DL model, trained on millions of images, learns to identify objects with incredible accuracy. It can recognize a stop sign, even if it's partially hidden by a tree branch or seen at a weird angle. This is deep learning, providing the advanced perception that makes safe self-driving possible. So you can see how they all fit together like nesting dolls. AI is the big dream, a car that drives itself. ML is the method we use to make it smart. It learns from driving data. And DL is a powerful tool within ML that gives the car its amazing senses. It uses neural networks to see and understand the world around it. All three work in harmony to take a wild science fiction idea and turn it into a reality you might see on the road today. It's a brilliant example of how layers of technology build on each other to create something truly intelligent.